leave them there for now. So this process is going to sound very familiar. In fact, what we're writing is going to look very familiar if you compare it to last Friday's notes. When dividing numbers in scientific notation, we're going to follow 4 simple steps, just like Friday. First thing we're going to do is divide the leading numbers. Okay, so our numbers out in front, we're going to divide those instead of multiplying them.
Thank you.
You're welcome, thank you.
That was not me, bro. I said, yeah, what I saw you did. You trust me. So the first thing we're going to do is we're going to divide our leading numbers. Then we're going to use the quotient rule. On our powers of 10. And in some of our problems that we see today, that's going to be it. That's all we're going to need to do. But with some, we're going to need step 3, which is to move the new leading numbers decimal until there's only one number to the left. Okay, that's a really long way of saying get the decimal where you need it to be. At this point, we should all know what that means. And then finally, we're going to take the number of spaces we moved and subtract it from our new power, or from our exponent on our new power of 10. All right, that's all the words that we need to write. Oops. And there's our first example when you get a chance to write that down.
So this four-step process here is exactly the same as last week. The only difference is we're dividing using the quotient rule and subtracting instead of multiplying using the product rule and adding. We're just doing the inverse. Okay? This was Friday's notes. Okay, and this is today. So it looks exactly the same. We're just basically doing the inverse of everything. So if we have something like 8.0 times 10 to the 6th over 2.0 times 10 to the 4th, our first step is going to be to divide the leading numbers. Okay, so step 1 gives us 8 divided by 2. So we set up our long division like that. Obviously, you don't need to do long division to do 8 over 2. But for these decimal numbers, you definitely will have to do some long division. 2 goes into 8 how many times?
4.
4 times, right? So our new leading number out in front is going to be 4. Okay? Our new leading number is going to be 4. Step 2, we got to do the quotient rule with our powers of 10. 10 to the 6th over 10 to the 4th gives us 10 to the 6th minus 4, just 10 to the 2nd. And when we multiply numbers in scientific notation, we add it. But here, we're going to subtract. Luckily, we don't need to do step 3 here. We can just write out our answer, which is 4.0 times 10 to the 2nd. Alright, so that's what that process is going to look like. Let's see what happens when we have to use steps 3 and 4, though, and things get a little bit dicey. Let's see. Let's do... Let's try out... Okay. 1.2 times 10 to the 6th over 5 times 10 to the negative 3. And this is off your worksheet you're going to get here, so we can talk about this one, so you'll have it. So step 1, we have to divide our leading numbers, right? We've got 1.2 over 5, so we can write that as 5 on the outside of our little division bracket, 1.2 on the inside, right? When we have a decimal underneath our division sign like this, what do we have to do? Because I know that looks weird, right? Does anyone remember what we have to do? Jordan, you remember?
Remove the decimal.
Remove the decimal. We could do that. We could bring this decimal over, but then we'd have to bring the decimal outside over. All we have to do is draw this decimal up top like that. Does that sound familiar to anyone? Hopefully. So when we're putting our numbers in here, we're just going to use this decimal and put our 5 on the other side. It's kind of hard to explain long division now that I think about it. But instead of 1.2, let's treat it like 12. Okay, 5 goes into 12 how many times? 2 times. 2 times 5 is 10. Subtract that and we get 2. 5 can't go into 2, so we need to bring a 0 down. And 5 can go into 20 how many times? 4, right? So our new leading number that we have is 0.24. Okay, we'll come back to that. Let's get our powers of 10 out of the way. 10 to the 6 over 10 to the negative third. 10 to the 6 minus negative 3. Be really careful. You got to make sure you put both minus signs when you're subtracting a negative number. And two minus signs next to each other, what do they come together and form again? An addition sign. 10 to the 6 plus 3 gives us 10 to the 9th power. All right? So the way our problem looks right now is 0.24 times 10 to the 9th. Now that's really close to the notation that we want, but we've got to go in there and change that decimal. So our new leading number is 0.24. Where do we want our decimal to end up in this number so that it's in the right spot? Do we move it behind the 2 or behind the 4? Azalea? Behind the 2, right? We want our decimal right there. We got to move it one space. Okay? When we move it one space, now we have 10 to the 9th minus 1. Not plus 1, minus 1. And the reason why we have to subtract a power is because whenever we divide two numbers together, we get something smaller, right? Division is a process that makes numbers smaller. So if we added 1 here, we'd be increasing our number 10 times, right? We'd be adding a power of 10. 0.24 is a small number, right? It starts with a 0. It's less than 1. So when we move that to the right, on Friday we were moving the decimal to the left. Now we're moving it to the right. We have to subtract 1, and we get 10 to the 8th. So our final answer is 2.4 times 10 to the 8th. Same exact number as 0.24 times 10 to the 9th. Same number, just in the correct notation. Let's see. How are we feeling about this so far? Show of thumbs. Up, down, sideways. How are we feeling? Even if you are thumbs sideways, I'd like to see just so I can get a gauge of how everyone's doing. Okay. I see a lot of up and a few sideways. That's good. Let's go ahead and stop there. And let's see how you guys can do with the worksheet.